So let's continue our problems on the 4 important points of concurrence. And here we have got 2 statements. This based on logic. Statement number 1 says we have a triangle with sides along x plus y is equal to 0, x minus y is equal to 0 and x is equal to 7, and the circumcenter of this triangle is at 7, 0. That is statement number 1. Now this needs to be evaluated. The second statement says circumcenter of a triangle lies inside it. All of us know that if you take an obtuse angle triangle, the circumcenter will definitely go outside it. So therefore statement 2 is straight away false. You know, in these questions there are 4 options A, B, C, D, and the moment statement 2 is wrong, we will very likely be going towards option C, that is statement 1 true and statement 2 false. But first let us look at the correctness of statement 1. Now if you simply draw a sketch, x plus y is equal to 0 is a straight line through the origin with negative slope, and x minus y is equal to 0 is a straight line through the origin with positive slope, and x is equal to 7 is a vertical line. So you can work out the coordinates. This will be 7, 7, and this will be 7, minus 7. And you know the slope of x minus y is equal to 0 is 1 and the slope of x plus y is equal to 0 is minus 1. So it satisfies the m1 into m2 is equal to minus 1 criteria. So there is a right angle here. Because there is a right angle here, the circumcenter is located at the midpoint of the hypotenuse. So this is the hypotenuse and this happens to be the midpoint. So 7, 0 should be the location of the circumcenter. So whatever is given in statement 1 is absolutely right. So statement 1 is true, statement 2 is false. Therefore, the answer to this problem will be C. Now we have in question number 12 2 statements. Statement number 1 says 2, minus 3, minus 4, 7 are 2 vertices of a triangle whose orthocenter is at the origin. The third vertex is at 5, minus 1. This is a statement which is made. Statement number 2 says orthocenter is equidistant from the sides of the triangle. Statement 2, as all of you know, is false because that point of concurrence which is equidistant from all the sides is the incenter. So orthocenter and incenter will coincide only in very rare cases. So this general statement is wrong. So we can straight away say statement 2 is false. So if only we can prove statement 1 is true, I think the option will be C. So let's look at this diagram in which 2, minus 3 and minus 4, 7 are given vertices, orthocenter at origin, and the third vertex 5, minus 1 is given. Let us take it as x, y. So let us look at slope of BC. This will be 7 plus 3 by 4 minus 2. That is 10 by 2, which is 5. So the vertices are 2, minus 3, 4, 7. So slope AD will be the negative reciprocal of this. So it is minus 1 by 5. Let us write the equation of AD. Equation AD, because it passes through the origin, can be easily written as y is equal to mx, where m is the slope which is minus 1 by 5. Minus 1 by 5 into x. Now let us look at this equation and see whether 5 minus 1 satisfies it. If 5 minus 1 satisfies it, then the statement is true. Now you can easily see when you put x is equal to 5, 5 and 5 will get cancelled and y will be equal to minus 1, which tallies with that thing. So therefore, statement 1 is true, statement 2 is false, therefore the correct option is C. Question number 13, another logical question in which statement 1 says we have a triangle with vertices a cos t, a sin t, b sin t minus b cos t, and 1, 0. And with this information, it is said that the locus of this centroid is this equation 3x minus 1 whole square plus 3y whole square is equal to a square plus b square. And the second statement, centroid is equidistant from the vertices. Again, we know that it's only the circumcenter that's equidistant from the vertices. So statement true is false. So this is false. Now let us look at the correctness of this statement. So first what we do is you compute the centroid. Of course, the centroid will turn out to be in terms of the parameter t. So G is equal to x1 plus x2 plus x3 by 3. So a cos t plus b sin t plus 1 by 3, and then a sin t minus b cos t plus 0 by 3. Because we are finding the locus, let us take it as x comma y. So you take x is equal to this and y is equal to this. Now when you do this, you can see that 3x minus 1 is equal to a cos t plus b sin t, and 3y is equal to a sin t minus b cos t. To find the locus, we know the parameter t has to be eliminated. From your practice in trigonometry, if you look at this pattern, a cos plus b sin and a sin minus b cos, squaring and adding will eliminate the parameter. Because when you square, you will get a 2ab cos t sin t here and a minus 2ab sin t cos t here. So they will get cancelled. Therefore, simple addition after squaring should solve the problem. So therefore, 3x minus 1 whole squared plus 3y whole squared is equal to, now let us see what are the square terms. A cos square plus a sin square is a square, b square sin square plus b square cos square is b square, and as I told you, the cross product terms will get cancelled, plus 2ab and minus 2ab cos t sin t. So therefore you can see that the statement which is made is perfectly alright. So statement number 1 is true, that the locus of the centroid is this, and statement 2, as we discussed earlier, is false because that statement is generally not true. So the option is C. Question number 14. This is based on multiple, choosing the correct option. So we have a triangle here, and the problem is to simply identify the incenter. So you know, incenter can be computed using the formula ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c, where small abc's are the sides facing the vertices big abc's. So what is required is computing the lengths of the sides a, b and c. Now you can easily see by inspection, small a is the distance between 0, 0 and 2, 0. So therefore a is 2. Now let's take b. B is the distance between these 2 points. Therefore 1 minus 2 whole square is 1 plus root 3 minus 0 whole square is 3 under root, which is 2. And finally c is this distance, which is again 1 plus 3 under root, which is 2. So you can easily see that the triangle has become equilateral. The moment triangle is equilateral, you know, all these concurrence points become coincident. So therefore what happens is, you can exploit the situation that incenter is equal to centroid instead of calculating like this. So the centroid of this triangle will be 1 plus 0 plus 2 by 3 and root 3 plus 0 plus 0 by 3. So, this will be 1 comma 1 by root 3, and option A can be located in the answers. So, this is how we can easily solve this. Of course, you can also cross check by this rule. In this problem, ABCs are already known. X1, Y1, X2, Y2, X3, Y3 are already the vertices. The student has got options to verify. Both the techniques should not take much time.